everyone, today we're going to be taking some of the knowledge that we learned from Chapter 3 and applying it to how to graph linear equations. This video is 2 parts, so once you finish the first part, make sure you watch the second. Alright, we're going to look at some examples. So, if you think you know what to do, go ahead and pause the video and give it a try. If not, we'll go through a couple and then you can pause after that. So, we're asked to decide which points lie on the graph. So, we're given x plus 3y is equal to 6. And then we're given the coordinate points 1, 2, negative 3, 3. So, let's start with 1, 2. So, remember a coordinate point tells us our x coordinate and our y coordinate. So, if we know our equation is x plus 3y is equal to 6, then what we can do is take our x coordinate, and anywhere there's an x, plug in 1, and anywhere there's a y, plug in our y coordinate 2. So we'll have 1 plus 3 times y, which in this case our y is 2, equals 6. So our job is to figure out if that statement is true or not. So remember PEMDAS, that's our order of operations. So we have parentheses, exponents, multiplication, division, addition, and subtraction. So we'll do multiplication first since we don't have any parentheses or exponents. So we have 1 plus 3 times 2, which is 6, is equal to 6. Then on the left we have 1 plus 6, which is 7. So we have 7 is equal to 6. And that's not true. So this tells us that the point 1, 2 does not lie on the line. Alright, go ahead and see if you can do the second point on your own. So we have the point negative 3, 3, and we're trying to figure out if it's on the line x plus 3y equals 6. Remember again, this is x and this is y. So anywhere there's an x, we'll plug in negative 3. Anywhere there's a y, we'll plug in positive 3. So we have negative 3 plus 3 times our y, which is positive 3, is equal to 6. Now remembering our order of operations, we do multiplication first. So we have negative 3 plus 3 times 3, which is 9, is equal to 6. Now we have negative 3 plus 9, which we can rewrite as 9 minus 3. So I just switched these guys around. I put 9 first and then minus 3 after it. So 9 minus 3 is 6. So we have 6 is equal to 6, which is true. So that tells us that the point negative 3, 3 does lie on the line. All right, see if you can do this next example on your own. Number 2 asks us if the points 2, negative 1, and negative 1, 2 lie on the line 3x minus 4y equals 10. So again, remember this is x, this is y. So anywhere there's an x, we'll plug in 2. Anywhere there's a y, we'll plug in negative 1. So we have 3 times 2 minus 4 times negative 1 is equal to 10. Now we have to do our multiplication first. So we have 3 times 2, which is 6. And then we have a negative 4 times negative 1. And a negative times a negative is a positive, so we have plus 4 is equal to 10. And then the left side of the equation, we have 6 plus 4, which is 10. And indeed, 10 is equal to 10. So we know the point 2, negative 1 lies on the line. And finally, we have the point negative 1, 2. Negative 1 is x, 2 is y. Let's plug it in and see if it works. So we have 3 times our x coordinate, which is negative 1. So 3 times negative 1. Minus 4 times our y coordinate, which is 2. And that is all equal to 10. Doing multiplication first, we have 3 times negative 1, which is negative 3. And then we have negative 4 times 2, which will give us negative 8. And then 10 on the right side of the equation. So we have negative 3 minus 8, which is negative 11. And negative 11 is not equal to 10. So that tells us that the point negative 1, 2 does not lie on the line. So that's how you determine if a point lies on a line. You just have to plug in our coordinates and check if the statement is actually true. Let's look at a different example. So number 2 asks us to find an ordered pair that is a solution to the equation. So for this one, we're kind of working backwards. We're taking a line and we're trying to figure out what are some coordinates, x and y, that would actually work if we were to plug them in. So the way we can do this is to just choose a random x coordinate. So for instance, I want to use x is equal to 0. So what I'll do is, now that I know that x is 0, because I decided that, I'll plug it into our equation. So we don't know what y is. That's what we're going to try to figure out. So I'll leave y on its own. But instead of x, I'll write 0, since that's what we said x was. So on the left, we have y still, because we don't know what that is. But on the right, we have 3 times 0. Anything times 0 is just 0. Minus 5. So y is 0 minus 5, which is negative 5. So we have our x coordinate, we have our y coordinate, so we can write that together as a coordinate pair. We have the point 0, negative 5. And that would be a point that lies on the line. Take a minute, go ahead and try to see if you can find another point that would lie on this line. Again, all you have to do is pick an x coordinate, anything you want, and then plug it in and try to figure out what y is. So I'll do another one. Let's try x is equal to negative 2. So again, we're just going to leave y because we don't know what that is. That's what we're going to figure out. But instead of x, we'll plug in what we said x is now, which is negative 2. So we have 3 times negative 2 minus 5. Again, I'm still just using this line. So y is equal to 3 times negative 2, which is negative 6. We still have this minus 5 here, so minus 5. So y is negative 6 minus 5, which would give us negative 11. So we have an x coordinate of negative 2, y coordinate of negative 11, so we can write that as a coordinate pair. Negative 2, negative 11. For part B, we have y is equal to negative 2x minus 6. So go ahead and pause this, try to find some coordinate pairs on your own. Again, just choose an x and then solve for y. So I'll just do 1 for this one. I'm going to choose something random again. So I'm going to do x is equal to 10. Because again, we can choose anything we want for x. So we have y, that's what we're going to try to figure out, is equal to negative 2 times our x, which we said is 10, minus 6. So y is equal to negative 2 times 10, which would be negative 20, minus 6. So we have negative 20 minus 6, which gives us negative 26. Our x coordinate is 10. Our y coordinate is negative 26. So our coordinate pair will be 10, negative 26. So that's how you find a coordinate pair on a line. Let's talk about function form. So function form is a linear equation written with y alone on the left side of the equation. So just like in question 2, we had y is equal to 3x minus 5. Well, since we have y all alone on the left and everything else on the right side of the equation, this tells us that it's in function form. Same with B. We have y all alone and then everything else on the right side. So let's look at how we can put equations into function form when they're not already in it. So remember back to lesson 3 when we were looking at solving equations. This is where that knowledge is going to come in handy. So we have negative 3x plus y is equal to 12. So remember, function form tells us that we need to have y all on its own. So what we need to do is look at what's happening to y that makes it not on its own, and then do inverse operations. So we have negative 3 being added to y. If I were to rearrange the left side of the equation, we could write this as y minus 3x is equal to 12. So I just flipped these guys around. Put y first, then minus 3x. We have negative 3x being subtracted from y, so we have to do inverse operations. The opposite of subtracting 3x would be to add 3x. And what we do to one side of the equation, we have to do the other. So we have negative 3x plus 3x. Those cancel out. Then we have y is equal to 12 plus 3x. And then when we write linear equations, we prefer to have the x term in front. So I'll just switch the 3x and the 12 around and write 3x plus 12. Go ahead and see if you can do the next one on your own. So for number 2, we have 2x plus 3y is equal to 6. So this one, y is not on its own. That's how we needed to get it in function form. So we'll look at what's happening to it that makes it not on its own. The first thing I notice is it's being added to by 2x. So I'm going to do the opposite of that. The opposite of adding 2x would be subtracting 2x. And what we do to one side of the equation, we do to the other. So our 2x's cancel. We still have 3y on the left. But now we have 6 minus 2x. And again, when we write lines, we prefer to have the x term in front. So I'll just flip these around. 3y is equal to, make sure that the negative comes with. So negative 2x plus 6. So again, just swap those two around. Y still isn't on its own, and that's because it's being multiplied by 3. So what's the opposite of multiplying by 3? Hopefully you said this, but we'll want to divide by 3. And what we do to one side of the equation, we do to the other. So we have y is equal to negative 2x plus 6 divided by 3. Now in our numerator, we have 2 terms, but in our denominator, we only have 3. So what we can do is separate this into 2 separate fractions. So negative 2x over 3 and 6 over 3. Kind of like we had 1 plus 5 over 2. Well, we could rewrite this as 1 over 2 plus 5 over 2. So separate it into 2 separate fractions. So we'll do a similar thing with our equation. We have y is equal to, we'll write negative 2x over 3 on its own, and we'll write 6 over 3 on its own. And we can go one step further, since 6 divided by 3 is 2. So there we go.